Hello and welcome to Tip Top C Sharp tutorial series. In this video, we will be discussing about one of the common interview questions in .NET C Sharp, boxing and unboxing. So for the agenda for today is first explain and explore what is a value type and reference type. Then we will get to know more about boxing and unboxing process, and we will have a set of points to think about. Okay. So when you consider data types in .NET Framework, especially C# programming language, we have two major types called value types and reference type. So what are the different characteristic of value types and reference type? How do you understand this is a value type and reference type? Let's go through each points one by one. So value types are stored in program execution stack. So stack is the data structure where you can push and pop. Whereas the reference types are stored in program execution heap. In .NET world, in common language runtime, we call it as managed heap because it is managed by CLR, common language runtime. And value types will directly contain the values, whereas reference types will be containing the references to heap. So heap is nothing but a dynamic memory which can be allocated for different objects. And this reference is nothing but a pointer, which is nothing but memory address, which will eventually resolve it to a location on heap. And what are the examples for value type? Primitive numeric types such as integer, uh, double, float, and we have character and boolean types. These are the examples for value types. And for reference type, it's classes, meaning that whenever you create an object of a class, it's a reference type. And we have interfaces. Whenever you have an implementation of interface, that is a reference type. And the string is a reference type. This is one of the questions that anybody can ask you. String, though it sounds like a primitive type in .NET C Sharp, it is a reference type. And obviously arrays, which are it could be integer array or any data type array. That is also a reference type. And value types, as I said, it's a primitive numeric character and boolean. It can have default value, but it cannot hold a null value. So it cannot be assigned a null value. For integers numeric, it will be the default values like 0, and for character, it will be 0th element, and for boolean types, it will be false. So there are different default values. Whereas reference types, we can assign null value. You create an object and assign it to null. You have an interface implementation, assign it to null. We can have a string assigned to null or even an array. And let's see the final point about value type, about the allocation and to memory. So when does it get removed from memory? When they fall out of scope. For example, you have a method and you have some integer value there, and when the method ends, the last curly braces is stepped through, then the variable is going out of scope. So that value type is removed from stack. Okay. But for reference type, the mechanism is slightly different. It is allocated on the dynamic memory, which is nothing but the program execution heap or managed heap. The allocated memory is freed up by common language runtime's garbage collector. So let's take a step below and understand in depth what is the memory allocation for value type and reference type taking place behind the scenes. So for example, value types, so there is an integer, there is a boolean. How does it get allocated in the stack? As shown here. In the stack, we have my integer and the value is 10. Let's say you are changing the value in the stack itself will be changed. And even for the boolean, the value is true here because we assigned true. And if you were changing it to false, again, this value directly will be changing on the stack. Okay. And we have two reference types as well here. For example, one is byte array. We have certain values allocated to the assigned to the byte array here. As you see, it will be allocated in the managed heap. And as for the string as well, when you assign a string, it will be created as a character array in the managed heap, and the pointer will be stored on the stack. So basically, if you have a variable my byte array that is holding the address of the byte array in the heap, and same for the string. So this is applicable for all the reference type. So this is the major difference between the memory allocation between value type and reference type. Very important point to know. Now let's come to the main question that we are trying to explain in this video. What is boxing and unboxing? So now that we understood value type and reference type, the boxing operation is defined as conversion of a value type into a reference type. To exemplify, here is a value type my int, my integer, and there is a object class, and we are creating an object and assigning the value type integer to object. So what happens behind the scenes in the memory allocation? First, when you declare the integer, it has value stored in the stack and the heap is empty. It has nothing to do with the integer allocation. Now, if you see the my object has been assigned to integer, the integer value now will be moved to heap because the object is a reference type which will not store the actual value in the stack. It will hold the reference only in the stack for in the variable. So the allocation is on the heap as you see here. So that's how boxing happens. So once you have the value moved to the heap and the pointer is assigned to the variable on stack, we can say that is a boxing. That is that value is being boxed in the heap. And the reverse process from where we convert a reference type to a value type is called unboxing. Like for example, you declare a new integer and take out the object and cast it. Okay. In this process, one important point to remember is this is an explicit conversion. If you see boxing, we just need to assign the value type directly to the uh, reference type. No need for any particular casting or boxing, but uh, whereas unboxing is concerned, we have to do an explicit casting to the target type. Okay. So there will be a lot of questions around this, certain points to ponder. So the first question that comes to your mind could be, is there any overhead for boxing and unboxing operations? Because we have seen a lot of things in action here. We saw that the value is being moved to heap and then the reference is created and the reference is assigned to the variable. So definitely there is a overhead associated with it. Okay. And once you say there's a problem or an overhead, the next question will be obviously how to minimize boxing and unboxing operations in your code. So one of the important tip is to use type-safe collections in .NET. If you haven't watched our videos on collections on generic and non-generic, you should please watch that. So always prefer generic collections over non-generic collections because non-generic collections like array list and hash table will incur boxing and unboxing operations, which will eventually lead to performance overhead. Another question is, can a value type be contained in a reference type? So we talked about two different data type hierarchy, value type and reference type. So can one be contained inside another? Definitely yes. Let's take a look at the code snippet. So this is a struct. Okay, struct is a value type. Okay, and I am defining my custom value type here, and I'm declaring some reference type here, string ID and public byte array. These two are reference type, and it is contained inside a value type. So that is perfectly permissible. And the next question can be exactly related to the same question. Can a reference type be contained a value type or a value type contained a reference type? So if you see here, I have a class which is nothing but a reference type, and it can contain a lot of value types. So these are permissible scenarios. There is no harm or there won't be any compiler error or warning for this one. That is by design. And final question will be, how does typecasting differ from boxing and unboxing? Typecasting you would have seen in a lot of programming languages, and once you enter in the .NET world and C Sharp, you get to know boxing and unboxing. And the first point of confusion could be this: how does it differ from typecasting? Let's take a look at the typecasting code snippets here. So here, typecasting is nothing but conversion of an expression to a given type. For example, I have my integer defined here. Okay, integer value is 10, and I am assigning it to double. By casting it, I am providing the type expression here. And if you see here, you will see some IntelliSense being run, and it is giving you some suggestion saying that cast is redundant. The cast is redundant when you cast it from a lower type to higher type. Double is having higher precision than integer. So we can actually remove this double syntax here because this is redundant. This will work. Whereas if you want to reverse cast it, that's not really the way. If you don't specify the target type, then you will get a warning saying that cannot implicitly convert double to int. An explicit conversion exists. Are you missing a cast? Yeah, definitely we are missing a cast here. We have to give the cast explicitly. And how about converting different types into reference type? For example, my integer I am trying to convert into a string. So there is no permitted conversion here. Even if you provide a string, cannot convert integer to string because to a different type system, and there is no permitted combination here. But there is a workaround for this in .NET because every type will have certain methods added to it. So if you see the toString method, you can definitely do this. Okay, this is a part of every object in .NET. That's what we did here. And if you want to assign that to an object, again we can do that. This is again typecasting, but as we did here, we don't need an explicit cast here. And again, if you want to convert it back to a string, again you need an explicit cast. So the answer to this question is typecasting can result in a boxing or unboxing operation, but not necessarily always. Even if you are casting between two value types, there is no boxing and unboxing. If you are doing between two reference type also, there are not necessarily a boxing and unboxing. But if you are doing between value type and reference type, typecasting will lead to boxing and unboxing. So that's all about for this video. Thank you for watching Tip Top C# tutorials. Have a nice day.